In the previous video, I was talking about why is this not writing? Hierarchical mobile IPv6 and how does uh, hierarchical mobile IPv6 allocate mobility anchor points to the mobile nodes which have a handoff. And in that we had two types. One was hierarchical mobile IPv6 and second one was hierarchical mobile IPv6 where the mobile nodes were assigned to the maps based on the velocity of the mobile nodes. We had the problem was the higher level maps were congested because they were assigned first in the hierarchical mobile IPv6, and in velocity based all mobile nodes, if they have the same velocity, then they are assigned to the same mobility anchor point. So only one mobility anchor point may get congested when all mobile nodes will be assigned to one mobility anchor point when they have the same velocity, all have the same velocity. So how does DEMAPS, the technique which I'm going to tell now, solve these problems? Let's see how does DEMAPS handle these problems in this video. So this is a simple diagram where the maps are in the hierarchy as in hierarchical mobile IPv6, but the advantage of DEMAPS or the speciality of DEMAPS is it assigns the map properly or efficiently so that the load is properly distributed among the maps, so that there few maps are not congested and few maps are not underutilized. It's like the load is properly distributed among the mobility anchor points. So the procedure it follows is all the maps will send their load to the access router. It may be at any delta t time. So it's like a map. Every map sends their load to the access router. So to send this load, they use some field called RES field, which is a 7-bit field. In this 7-bit, the first bit will have the load increase and load decrease tendency. If it's like 0, load increase, and if it's like 1, it's load decrease tendency. So, and the rest of them will contain the load in the map. So map will be sending the RES field, which will be containing the load, to the access router. Now in the 6 bits there will be load. The load will be like 2 power is given in 6 bits. So 6 bits can store 2 power 6, that is equal to 64 values. So what the load is actually given in percentage. So if I give in percentage, there should be 100 values, but why 64? It's simple. Only the top 64 values are considered as load, because 0 to 36 is considered to be null, that is low load. So we're not worried about this 0 to 36, and from rest 37 to 100 is specified in this 6 bits. So if the load is 36, then no problem, it's lower load. If it's more than 36, then it indicates that the load is going increasingly, or it's increasing over time. 36, 30, maybe 40, then it goes to 90, then it gets overloaded 100. So 100 will be represented by 2 power 6, that is 1 1 1 1 1 1, 3 bits 3 bits, 6 bits, and 36 is not represented. 37 may be represented by 0 0 0 0 0 1. So 37 and 38 is 0 0 0 1 0. So 100 is this. So if the res field contains 1 1 1 1 1 1 3 6, yeah, then it means that the load in the map is 100%, so it's congested. So now you know how the load is sent to the access router. So the map sends load to the access router. Now what is that first bit? Load increase and load decrease tendency. It's nothing but there will be some expected load that the map calculates, and there will be the actual load. The actual load. So for example, at 10 o'clock the load, expected load is 50%. This is calculated by a map, mobility anchor point. Now if the expected load is 50%, and this may be calculated at maybe 9, that in future at 10 o'clock we expect a load of 50%. When the time is 10 o'clock, we see the actual load. If the actual load is 80%, then the load is more than what we had expected. So it's a load increase tendency, and this load is not calculated per hour, it's calculated per delta t. The t may be 1 second, or it depends on the operator, the network operator. Airtel may say, okay, I don't want at 1 second, let it be for 1 minute. So then it will be like 10:01, 10:02. So 10 o'clock 1 minute, 10 o'clock 2 minutes, they'll have expected load, and which will be calculated based on the by average, exponential moving average method, which I'll be talking later. So just you need to know what is load increase and load decrease tendency. So if the load is more than what was expected, then it is a load increase tendency. And if at 10 o'clock we expected 80% load, which was calculated before 10 o'clock, and at 10 o'clock the actual load was some 60%, then the actual load is less than what is expected, so it's load decrease tendency. So you just need to know what is load increase and load decrease tendency. So the rest of the things I'll tell you how to calculate later. So now what happens here? It's just the mobility anchor point sends the load via the res field. Res field is 7 bits. The the load is sent every delta t second, and it's calculated and it's selected by the network operator, and the 7 bits contain the load increase tendency and load decrease tendency in 1 bit, and the rest 6 bit contain the load, that is from 37% to 100%, what is the load at the map. Now once the access routers get the load of each map, that is this access router will get the load of this and this map, because it comes under these maps in the hierarchy, and even this access router gets this and this map, and this access router gets this map and this map. So these two maps are the options that send their load to this access router. Similarly to this access router, these two maps, and this map's load will not come to these two access routers because they are not in the hierarchy. Similarly here I'll select only one, so this access router will get this map. So 3 loads, that this will send the res field, this will send the res field, and this map will send the res field to this access router. Now what will the access router do when it knows the information of the load of each map? The access router selects one of the maps for the mobile node that is having a handoff. So if the mobile node was under this access router and it is moving to this access router, then it will check the load at this map and this map. If assume that the load was 50% here and the load here was 40%. So it has two options. Let me consider this as map 1 and this as map 2, and I'll calculate here. So map 1 load is 50% and map 2 load is 40%. And as I told earlier, the RES field will also have a load increase and load decrease tendency. So load tendency is load decrease tendency and this has load increase tendency. Then, or both have load decrease tendency. Then the access router, that's this access router, will select map 1 for this mobile node. And okay, that's fine. Now what the mobile node does, that's I will tell later. Assume that the mobile node moves here and it comes to this map, and the mobile node was registered to this map. Now it has had a handoff, and again this access router will have to select one of give the maps or map options. It will know the load. Assume that at this point of time when the mobile node had a handoff, the load here is 70% and the load here, now this is not considered, here is 65%, and the mobile node was registered here previously, that you have to remember because map 1 was selected. Again I'll call this map 1 and this has map 3. So the access router, that is this access router, will calculate map 1